I am Alan Chong, a teacher from the Department of Electronic Engineering of Southern Taiwan University of Science and Technology. First of all, we'd like to introduce the implementation of this course in the experimental environment. As the students have seen, the environment construction of this course is to imitate the environment of a care institution or a hospital as our practice environment. In this environment, we provide a lot of experimental equipment, including the simulation environment and facilities required for the elderly in institutions or hospitals to detect motion and hospital safety or institutional care safety. By providing complete equipment and a constructed environment mechanism, students can learn to make some works in the classroom through the combination of the courses and the practical space. Because this environment is simulated, especially the 4 beds on my right or the beds in the nursing institution are built to completely simulate the environment of a hospital ward or a nursing institution. So some works related to physical fitness or torso identification can be tested in this environment and verified in the field, and future works can be directly transplanted into the environment of hospitals or institutions. The above is my introduction to this environment. Hello fellow students, after introducing our field of practice, then in the online teaching or video teaching materials of this course, I will introduce how to use thermal imaging to detect the torso of the elderly or care recipients. The well-known past action or torso identification mainly employs 2 techniques. One of the technologies is to use RGB cameras to capture the images of the care recipients, and then transmit the images to the cloud server to identify the actions and behaviors of the care recipients to decide what kind of care services to do. However, the part with images will involve the issue of outflow of privacy rights. Therefore, there is another solution that is to let the care recipient wear related devices, which are devices we often see, such as bracelets or shoes, which can be worn on the body to detect their current movements. Then, the algorithm of the data is used to judge the current state of the care recipients and provide them with appropriate care services. However, the disadvantage of the wearable is that it needs to be worn on the body, and the elderly do not like it. The second is that it will cause inconvenience if it needs to be charged regularly, but the most important thing is that the accuracy of the wearable is relatively low. Because wearing the wearable device will generate a lot of noise interference in different parts of the body. Therefore, the method of motion detection to generate images can also provide different solutions whether the elderly are in the hospital, institution, or home. In the course of last semester, we have designed an AI edge computing device in order to solve the problem of privacy of image outflow. That is to say, the images captured by the imaging lens do not need to be transmitted through the internet, but are directly sent to the edge server terminal at the home, institution, or hospital. This server terminal may be placed in a ward or institution. Therefore, after the image is calculated by the edge server, the event can be calculated, and the corresponding service can be provided. In this way, the problem that the image is sent to the internet and the image is outflowed can be solved. However, there are also some problems. Although there is no outflow of images, there are still some places, such as toilets or devices with RGB imaging lenses that cannot be installed. According to current legislation, such equipment cannot be installed in the rooms of institutions or residents because of concerns about privacy. Therefore, even if it is such a device, its use is still limited by the factors of the environment and conditions. So in this course this semester, in order to further solve such a problem, we have switched to using thermal imaging lens. That is to say, the thermal imager is used to detect the thermal image of the human body. Through the learning of thermal imaging AI, the backbone recognition and the detection algorithm of the back movement can be used to provide different services for the elderly in motion detection in unlimited fields and unlimited environmental conditions. Therefore, in this course, we will introduce 2 cases later. The first case is to use the lens of thermal imaging to solve the problem of the high rate of falling out of bed for the elderly at home or in institutions or hospitals. By finding their skeleton, and then according to the movement of their skeleton, to determine their activity state in bed, and whether there is a tendency to leave the bed, and then notify or inform the caregiver. In this way, the elderly can be assisted when they leave the bed and avoid the chance of them falling at the bedside. This is the first application. The second application, we hope to provide the elderly with relevant physical exercise at home through thermal imaging to reduce the problem of sarcopenia due to lack of exercise in old age. The problem of sarcopenia, in addition to causing insufficient cardiorespiratory endurance and insufficient muscular endurance, its biggest problem is that it will increase the risk of falls and further increase the risk of death for the elderly. So how to effectively provide a device that allows the elderly to do appropriate physical exercise and give feedback on their activities at home, in institutions, or in any environment without infringing on the right to privacy is another very important topic. Therefore, two students will further introduce the following two works, namely, the use of thermal imaging lenses to prevent the probability of falling at the bedside, and the use of thermal imaging cameras with AI to provide the environment for the elderly at home or in institutions to do physical exercise. According to the statistics of the Ministry of Health and Welfare, falls of the elderly are the first in the notification of accidents. 80% of falls occur around the bed, and are most likely to occur when getting up and down the bed. There is a big reason for it due to poor vision and loss of balance. The Ministry of Health and Welfare has suggested that families should pay attention to the lighting and anti-skid measures in the home for the fall of the elderly. It can be seen that the annual medical expenditure caused by falls of the elderly exceeds 2.7 billion Taiwan dollars. So we have come up with the iLight product. It is a night light designed by our team. It is embedded with a thermal image sensor and consists of an AI edge computing device and a cloud care platform. When the thermal image sensor in the night light transmits the image to the AI edge computing device for recognition, if it detects that the elderly has the action of getting up and getting out of bed, the light will automatically turn on and notify family members or caregivers to carry out timely assistance to avoid falls due to poor vision or loss of balance. To use it, simply hang the night light on the wall and place the AI Edge computing device by the bed. Our technology is derived from OpenPose's human joint capture technology. In the process of development and clinical verification, the privacy problems of traditional RGB images are often encountered. Although we have strengthened the solution such as no image leakage and only outgoing events through edge computing technology, the doubts about traditional RGB cameras have not been resolved. Therefore, we have built the world's first thermal image torso identification dataset, namely the TH OpenPose Human Torso Identification Model. It contains a variety of tall, short, fat and thin human torso samples, with a total of 12,000 thermal images of the torso, and even users who have not been sampled can use it. We have also modified the neural network architecture of the native OpenPose module, which we call TH OpenPose Lite. It can achieve real-time operation in edge computing devices, and can accurately identify human body frames in thermal images. The second device introduced is the iMirror, a health promotion system for home physical fitness assessment and assistance. The main background demand is that as the world moves towards an aging population, the disability problem of the elderly also emerges, and sarcopenia is one of the main symptoms. Falls due to sarcopenia have a 20% chance of dying each year, and effective physical activity can reduce the risk of sarcopenia by 90%. However, the problems faced by the elderly during exercise today are: first, they need the assistance of a counselor. Second, they need to manually record the exercise standard. Therefore, physical fitness exercise has not been able to be fully popularized in the community or at home. In this regard, we propose a health promotion system for home physical fitness assessment and assistance, called iMirror. It is very simple to use. Just adjust the height of the lens to the same height as the user. First, register and log in to the system through face recognition. After successful login, the user can choose any sports item to start exercising. During the exercise, the system will continuously detect changes in human posture to calculate the exercise standard. Finally, at the end of the exercise, upload the exercise data to the cloud management platform, and send the push notification to the mobile app, so that the administrator and family members can check the elderly's exercise status. Next is the system process. Our system will obtain continuous images through the camera lens, and then transmit the images to the AI Edge computing module for image inference in OpenPose. OpenPose is an AI module for gesture recognition. First, the input image will be processed by the PAF's module to generate the human torso vector diagram, and then the thermal image of 18 human body joint points will be generated through the CMP's module. And finally, the human torso will be constructed by combining the vector graphics and the thermal images. Our system researches and develops its own physical fitness action algorithm based on the human torso map output by OpenPose, which can identify and judge the motion standard of the torso. Since OpenPose is an inference module built on a large server, if it is directly transplanted to an embedded device, there will be a problem of insufficient computing power, which will result in blurred images during fast motion, making some joints unrecognizable. Therefore, we have modified part of the neural network and replaced the original heavy VGG19 with the relatively lightweight MobileNet V2 to reduce the overall calculation amount and speed up the computing speed of the AI module on the edge computing device. In the part of physical fitness exercise for the elderly, we use 7 internationally recognized fitness exercise indicators as the exercise items of this system. These 7 physical fitness exercises can effectively improve the body functions such as flexibility of the upper and lower limbs, muscular endurance of the upper and lower limbs, dynamic and static balance, and cardiorespiratory endurance. We have completed the algorithm design of 6 exercises. During the design process, we have observed each exercise movement and collected the angle, length and position changes of the joints and backbones, so as to find out the behavior pattern of each exercise movement and differentiate and calculate the action criteria for each movement. The last is our demo video. First, after logging in through face recognition, the user can select an item to start exercising. During the exercise, the system will continue to recognize the motion and calculate the motion standard of the exercise. After the exercise, the system will automatically upload the exercise data to the cloud management platform for storage, and send the mobile phone push notification at the same time, so that the administrator or family members can check the exercise status of the elderly at any time. The above is a detailed description of the health promotion system that iMirror applies to home physical fitness assessment and assistance. According to the descriptions of the above 2 cases, I believe that all students can clearly understand how to use thermal images. After capturing the backbone of thermal images through artificial intelligence, different algorithms are used to provide applications of different care services. I believe that such online digital course materials can provide a reference example for precision care or precision medicine in the future. Also, because of such teaching materials, it can provide a different learning path for students who cannot take classes in physical classrooms. Finally, I would like to thank the Ministry of Education's Talent Cultivation Program and National Cheng Kung University for their assistance in providing relevant resources, so that our teaching material can be recorded and provided to more students with different and diverse learning channels.